Right. Is it clear to everyone? Okay, thanks. And also, again, because this one is really not convenient. If you feel like my voice is low, just ask me. I'll try to increase my voice. But same time, I'm trying to avoid being too loud. Okay, so yeah, sorry for a little bit delay. And I really recommend you guys to think about that deep learning certificate program. If you really want to, like for example, in the future, you want to do some job related to machine learning, artificial intelligence. Deep learning is some technique you must know. Yeah, so yeah, I will post the slides, all kinds of stuff on the Canvas, so you can take a look if you're interested. Okay, so and by the way, we have released homework 0, as we mentioned in our first lecture. This homework 0 is purely, text problems. It just asks you to review basic math knowledge that is required for this course. So please start doing it as soon as possible. As we mentioned, like we have 2 weeks for you to decide whether you're going to take this class or not, right? So I think it is always good, like to have some kind of experience. If you feel good about those problems, I feel okay, this problem is too easy. Well, yeah, welcome to join our class. If you feel this problem is too hard, too difficult, you don't have any clue, or you're sick of it, or even are pissed off by this problems. So yeah, and you can talk to me. I feel like not confident about this course. Just talk to me, or you can make your own decision. Again, we offer machine learning class every semester. We offer spring, we offer fall. So I mean, don't get frustrated like you have to drop this class this time. As long as you feel like, okay, you are well prepared, feel free to come to our class again. Okay. But again, I mean, we'll recommend you guys to start doing that homework early, so that you can get a sense that whether you like this course or not. Okay, so today we're going to continue explaining the course policy and requirements, all kinds of stuff, right? As we mentioned in the last lecture, the most important website for this course, I mean, in addition to Canvas, will be this course website. And we release almost all the information, which is same as the syllabus in this course website. So you can find out all the information here. And it is very easy to find this course website. You can just search my name in Google, and this is my Chinese name. It sounds weird. It looks weird. Yeah. But if you just scroll down the web page, you see the teaching section, and there's a link pointing to our course website. And that's it. And schedule of this class every Tuesday and Thursday from 9:10 to 10:30 at this big fancy classroom, right? At the same time, we're gonna stream our lecture to a YouTube channel, which is called UFU Data Channel. So again, joining the class in person is not obligatory, but we still highly encourage you to join the class in person, because that will make your interaction with the instructor much more effectively. If you just watch the videos, in YouTube, I mean, live videos or offline videos, whatever, I won't be able to answer your questions, right? And even you want to ask questions, I cannot answer them immediately. But in the class, you can stop me or interrupt me at any time point. I would like to discuss with you about the course content, or clarify some things. Like, according to our experience, like effective participation of the class can largely reduce your time. Right? Everyone is multitaskers. I believe you guys have registered multiple classes, right? So I think a wise strategy will be learn the best with the smallest amount of time. Right? So yeah, again, highly encourage you guys to join, although this is not obligatory. And final exam is on December 15th, Friday, from 8 a.m. to 10 a.m. Again, we might schedule this final exam just online to everyone for everyone's convenience. But we need to consider for a while. We might also take a vote when we approach the end of semester. So it has yet been decided. And this is my office, is in the MAP building 3466, and we got 3 TAs, and we schedule our office hours to be open for every weekday, Monday, Tuesday, Wednesday, Thursday, and Friday. We want to offer as much help as we can, right, for you guys, right? So that means we would like you guys to take advantage of these office hours, right? This is something we emphasized in the last lecture, but please bear with me. I would like to emphasize again because it's really important. Like, we intentionally put a large amount of office hours on Friday because according to our experience, the most quality office hour will be on Friday, usually the due day of the homework assignments. But again, to effectively leverage or effectively seek for help, I still highly encourage everyone to start doing homework early, so we can stop by our office hours on other weekdays, right? Rather than just Friday, because usually Friday there will be a lot of students like seeking for help. Okay, so now let us go through the syllabus. Larger. Okay. Again, we want to walk through this. The detailed syllabus is just to express explicitly what is the meaning, what is the requirement of this class, right? What is our expectation, how we're going to grade your homework assignments, how we're going to give you the final grade. I want everyone to be clear about, specifics of this class, so that you have enough time and you're clearly about everything, every aspect of this class. So based on that, you can make your own choice. So this is a course webpage. This is our teaching assistants. This is our office hours. They're the same as posted in the course website. So what's the general summary of this course? Right? Our class, right? Our course introduces basic knowledge of machine learning. By the way, is it clear to everyone? Okay, thanks. And topics consist of several fundamental and widely successful supervised and unsupervised learning algorithm, such as decision trees. That will be our first machine learning model and algorithm, perceptrons, deep neural networks, kernel methods, support vector machines, and probabilistic models. Right? So what kind of expectation we hope, like our expectation? We hope that after taking this class, you will understand machine learning ideas and paradigms. There's like one consistent paradigm, the framework of doing machine learning, right? You're able to identify or select appropriate machine learning problems for your research applications. So I think you will get a sense when you are doing your project, right? Not all projects are appropriate for machine learning, right? So you need to decide if this problem has a chance to be addressed by machine learning, right? You need to explain the rationale in your project report. And third one, you're able to design machine learning methods and implement learning algorithms, right? Of course, if there are appropriate tools, you can just leverage existing tools, like for example, in PyTorch or many libraries based upon PyTorch, you might just call you might just construct like a convolution neural nets, residue neural nets to do whatever you want, right? So, but we hope that you will be able to quickly identify appropriate tools for you to address your problem. So books. So we don't have a designated books for this course, right? I feel like, okay, asking everyone to buy some book or that's not very good, right? And so we make our lecture slides to be self-contained, meaning that it is enough for you to just look at the slide content to study all the all the topic we discussed in this class. But of course, if you want to learn deeper, you want to learn more, we gave a list of references books. Like if you like to investigate, if you have enough time, yeah, feel free to check them out, right? So the first one is it's called Probabilistic Machine Learning, a Probabilistic Perspective. It's a very, very thick book, about 200 pages, right? So I usually use it as a dictionary. And the second one is called Pattern Recognition and Machine Learning. This is more like a Bayesian machine learning, a probabilistic machine learning. It's a little bit stretched, I mean, to our to the topics we discussed in this class. But but this is a very classical book. If you're interested, take a look. And this third one is a course in machine learning. This is also a good introductory content to machine learning. There is many overlaps with our course content. Feel free to check out. And this one is written by 3 statisticians in Stanford. It's called Elements of Statistical Learning. Right? So if you're really interested in the statistical foundations of machine learning, feel free to check out. But the flavor is more like traditional statistics. Honestly, I don't like it very much. But if you like it, yeah, feel free to check out them. And this one is a very inspiring book. It talks about like connection between information theory, probabilistic inference, and learning algorithms. It's an old book, but it's very, very classical. So if you have enough time, you're curious about how the curriculum of machine learning is developed, right? It's based upon like classical, other classical curriculums like information theory, like probability, right? You can take a look. Okay, so far any question?
You talked about using like tools like PyTorch and sklearn and stuff like that. Some of the other classes, like we're doing the algorithms from scratch, like creating classes for like a node for we're not doing that in here.
Oh yeah.
That are already frameworks that are already developed.
Yeah, that's a very good question. We got like 2 types of things to do in this course. Like first type of thing is the homework assignments. There are a lot of like practical problems. For that one, you have to develop the algorithms from scratch. You are not allowed to use, like for example, in sklearn, you might just call one function call to create a decision tree. That's definitely not allowed. You have to implement the the tree construction algorithm recursively by yourself, like ID3, right? Or you cannot call any PyTorch library to implement backpropagation. You have to implement backpropagation by yourself. That's one thing, right? Another type of thing is called cross project. You can choose. We're gonna go to that details later. But for cross project, you're free to choose any libraries, and we encourage you to leverage existing tools rather than build the wheels from scratch. Other question? Okay, perfect. So here are the prerequisites. I think, I know that prerequisites sounds kind of very annoying to many of you. But what do these prerequisites mean? It just means that we hope that, right? We assume that you are well prepared to this class, not being suffered from this class, right? So what kind of background or foundations we would like you to have, right? First, we hope that we assume that you know basics about probability theory and statistics, right? This is not a statistics course. I won't like go deep into math, right? But many algorithms, ideas, or concepts based upon those existing foundations, right? We would like you to know the basic concepts, right? And second one is that we assume that you're familiar with linear algebra, vector matrix derivatives, those kind of stuff. You're not sick of operating matrices, right? Because in machine learning world, like we're dealing with data, we're dealing those are often represented just by matrices or tensors, right? So we talk about the algorithms. We assume that you're dealing with those matrices or tensors in some abstract space. That would be convenient to express the idea. So that's why we ask you guys to be not sick of those notations and operations. Otherwise, you might be, lost in those algorithm steps. Right? And third one, we assume that you have the basic algorithm design and programming debugging skills. This course really emphasizes on practice, right? We do want you to implement those learning algorithms from scratch, and you need to debug it, make it run, and generate reasonable results on a given data set. And those data sets are small, pretty small, and has already been pre-processed, so you don't need to worry about that. However, those are real data sets, real world. These are not like a fake data sets or synthetic data sets. So we do want you to make sure that your algorithm is runnable on those data sets and can generate reasonable results. Only doing that can reflect, okay, you indeed master this algorithm. You indeed know how this algorithm works, right? That's why we would like you guys to have the basic programming and debugging skills, right? And sometimes you feel that, okay, you understand this whole algorithm procedure perfectly well, but it just doesn't work. Why? And the answer might be hidden in a lot of like subtle details. There might be some bugs, right? You need to be patient enough to pick out those bugs and to address that. And we won't be able to help you to find out those bugs. You should be able to do that. Okay. Okay. Getting help, right? That's something actually I emphasize again, right? So we to effectively, for the effective learning, right? We encourage everyone to take advantage of the instructor and TA office hours, right? We posted on the course webpage, and we work hard to be accessible to students, right? So if you really have a special situation such that you cannot come to the office hour of any weekday, and we do want to meet outside the office hours, please send me an email or send an email to the TAs, right? And don't be shy if you don't understand something, right? Come to the office hours, send emails, and speak up in the class. There's nothing to worry about, right? However, if you hide problems, right, and the problems can accumulate, and when the semester goes on, it will make you more and more panic. I'm sure about that. So if you have any problems, have any difficulties, try to address them as soon as possible. Like seek help from me or from the TAs, right? And so you can go smoothly with this class, right? So again, we want you to learn what you want to learn from this class rather than being suffered or being tortured by this class. I want you to succeed in this class. So we'll use Canvas for the question and answer section, I mean, online, right? And if you cannot come to the office hour, if you still want to ask, feel free to post questions regarding any question related to the class, right? And our TAs are watching the Canvas actively. Of course, after 5 p.m. or during the weekends, they might not be able to answer a question in a minute. So please bear with them, and they will try to answer them during the working daily hours, right? And you're free to ask questions regarding or clarification about any course content or algorithm we discussed in class or theory we discussed in class. However, do not post potential answers to homework assignments. Okay? I mean, you're encouraged to like form a study group offline, like use 3, sit together and discuss, okay, how can I solve problem 2 in text problem section, or how can we implement algorithm 3 in programming section. And it's totally open for you guys to talk about the solutions, and even you guys can clarify each other and to make agreement. That's totally doable, but don't post your potential answers for some specific homework assignments online. The reason is that if you form a study group offline, right, you're discussing with your fellows, right, your fellow group members, you're motivating each other. Right? However, if you're doing this online, you post your answers in that, and somebody will just copy and paste, right? So that's not allowed. That's why like we're not in any kind of objection of you guys like communicate, discuss, and about how to do the homeworks, but we do want this kind of like a mutual communication rather than just follow someone's answers. Okay. So if we unfortunately found such posts, our TAs will immediately remove them, and we're gonna send message to whom post that kind of question and ask them not to do that again. And also, we may have from time to time we may make some kind of important announcements like deadline for homework 2 or deadline for midterm report, or there might be some change of this class schedule. Sometimes there might be some emergency situation tells that we have to cancel class, everything, or we have to convert the class to be online. There could be some issue, like for example, if there's some winter storm or some traffic issue, and we have to convert them in long. All those will be announced on the Canvas. So please just be aware of the Canvas notice. Okay, any questions so far? Yeah, feel free to interrupt me about anything we discussed for this syllabus. Okay, so what are we going to talk about in this class, right? So here is just a list of tentative outline. In my experience, like most likely we're not able to cover all of the contents here. We're ambitious, but we're never able to finish all those topics, right? We're gonna focus on supervised machine learning. And why? Because this is the most important and most widely used technique in the machine learning practice. And if you know the framework and methodologies doing supervised learning, it's very easy to transfer to unsupervised learning or semi-supervised learning. So that's this branch, like supervised branch machine learning, is our major branch to talk about. Like if we got some time, like we might talk about like typical unsupervised learning algorithm, like k-means clustering and Gaussian mixture models. And also we'll talk about some practical guidance, right? We're gonna introduce a few guest lectures from time to time. That is to introduce like popular machine learning libraries, like typically PyTorch. And a few years ago, when I started teaching this class, I asked my students to introduce TensorFlow. Unfortunately, TensorFlow is not as popular as before. It's kind of like people are starting to throw them up. Right? There's a new arising framework called JAX. That was still developed by the old TensorFlow team by Google, right? But it's much more elegant, much faster, and much easier to use. So probably we're gonna have some guest lecture talking about JAX. Right? But PyTorch is also very important too. Right? Okay, and for the supervised learning, we'll start talking about decision trees. Right? It was invented about 40 years ago, but it's super popular, super successful, right? And why should we start from decision trees? Because you see that the working mechanism of decision trees is really, really similar to how human beings make decisions, right? Every time, just pick up one decision variable according to his observations. We made one type of decision. We'll go branch 1, right? Go branch 2, and then we'll look at another decision variable, and according to status, we go to branch 3, and go on until we reach a specific decision. Right? It's very like human beings' decision procedure, so it's very intuitive. We'll start with that, and then by looking into some behaviors of decision trees, we're going to introduce a very, very important concept in machine learning. It's called overfitting, right? So nowadays, if you look at papers or look at discussion of machine learning engineers that say why your model, why your network doesn't work, and so on, like most time they're talking about, okay, perhaps it's your model is too big, it's overfitting, right? We're talking about what is overfitting, right? And when overfitting is harmful, right? It's actually people will overfitting is bad all the time. It's actually it's not, right? So actually overfitting is bad only when your data has noises, and unfortunately in practice your data always has noise. That's why overfitting is not good. But if your data doesn't have any noise, overfitting is not bad at all. And we'll talk about the most commonly used strategies to alleviate overfitting. It's called cross validation, right? And you will see that. I mean, this is very basic. The very basic technique for you to choose your model and tune the hyperparameters, right? And we'll talk about the boosting ensemble learning based on decision trees. You see that this is like a very smart and interesting technique that how do you smartly combine instead of like stupid machine learning models and algorithm. You assemble them into a much more powerful machine learning algorithm. So one method is called boosting. The other method is called ensemble learning, which includes random forest. And then we'll talk about linear regression and linear classifiers. So you see that linear regression, linear classifiers, as the name suggested, assume that the output of interest is kind of linear combination of the features you have. It seems very straightforward, but throughout our discussion, you see that it actually represents a super powerful set of models and algorithms, because by doing some kind of feature transmission, you can easily extend your linear classifiers or regression models to highly nonlinear models, right? And then you will see the so-called feature mapping technique converted into the so-called kernel methods. Then then it leads to the so-called support vector machines, right? That's the dominant machine learning algorithms before the resurgence of deep learning around like 2012, right? But now this support vector machine is still widely used, just because it's so mature. Like there are not too much research on that. Like people just use it like off the shelf too. And then we'll talk about like probabilistic learning, like that is how do you give some probabilistic meaning for linear classifiers. We're going to talk about logistic regression, naive-based classifiers, like what very widely used in online advertisement and recommendation. Then we'll talk about nonlinear classifiers, like especially kernel tricks, right? So we'll talk about how do you extend the plain support vector machines to nonlinear kernel methods. This is actually a series of very elegant mathematical trick. That will be the most dense part, I mean, in math in this class. But it's not hard. I guarantee it's not hard, but just there are quite a few steps, and you have to do some kind of analysis, and you have to be patient on that, but don't be scared. Just as long as you're patient enough, you're careful enough, it's not hard at all. Yep. And then we'll talk about deep neural nets. I guess this is the most students who are in favor of or prefer, right? So unfortunately, we're not talking about convolutional neural nets. We're gonna talk about transformers. We're not talk about general adversarial neural networks. We won't talk about this fancy and modern networks. We just talk about the fundamental architecture, which is called multi-layer perceptron or feed-forward nets. The motivation for this is to get clear what is the working mechanism of deep neural nets, and what is the foundation to effectively train deep neural nets, which is called backpropagation. You can see that whichever modern architectures you choose, you have to rely on backpropagation, right? So we need to figure out what's the mechanism of backpropagation, right? How do you effectively and efficiently implement backpropagation? later you'll see is backward essentially is just a smart leverage of the chain rule, the basic rule in calculus 1 or calculus 2, I forgot. Anyway, it's just the application of chain rule. Okay. Yeah, and then K-means and Gaussian mixture models are just the commonly used cluster algorithm. They belong to unsupervised learning because we assume that the data doesn't have any labels. So you want to find out patterns in the data. So you want to do some clustering. Okay, any question regarding our tentative schedule of the course topics? Okay, so grading policy, right? That's very important. That's that decides which letter grade will show up in your transcript, right? So we're gonna break down our final grade into 3 parts. Right? The most important part is the homework assignments. Right? So the homework assignments will take 50% of total grade. You can just will like its importance 0.5, right? And then we got 30% of grade allocated on the course project, which is also very important. And eventually we'll have one final exam, which takes 20% of total grade, right? It's not as important as the course project and homework assignments, but you still need to make some reasonable amount of efforts to get A, right? So, for the homework assignments, we got 6 homework assignments in total, including homework 0 we released on Tuesday. Right? Typically, each homework assignment, other than homework 0, right, will contain both analytical problems and programming assignments. Right? And analytical problems is very easy to understand. I just ask you questions and you just give me the answer, right, written in text. Right? The programming assignments usually require you to implement particular machine learning models and test them in real world or synthetic data sets. Sorry, there are no synthetic data sets. I should remove this word, right? And each homework problem might have a different number of points and depending on the work amount, right? To finish the, like for example, a typical programming assignment problem would be, okay, we have talked about ID3 algorithm for constructing decision tree. Okay, here we collect a data set, which is about like bank users information. I want you to predict whether you're gonna give some loan to this user or not, right? Based on upon their basic information, you should be able to know. You should be able to capture if their financial situation is good or not, right? If they can afford to the mortgage, right? So if you want to build a decision tree to make such kind of prediction, right? So please implement your ID3 algorithm, then train on the training set and test on the test set and report us the accuracy. Then we may ask you to implement several variants of ID3. Of course, those are covered in our class. Like for example, the classical ID3 will be using information gain, right? And I might ask you to implement Gini index or majority gain. We'll cover them in class, right? But you need to implement them. And then test them and compare your performance on the different variants, right? Which one is better? Show me the results, show me the table, and give you your explanation or your sense about why using Gini index is better. Okay. So typical problems like that. Right? So regarding what kind of programming languages to implement those algorithms, there's no restriction on the specific language you use, but we highly encourage you to use Python, MATLAB, or R for the programming because those 3 are the most popular programming language used in machine learning community. Right? And right now it's I guess 80% of machine learning program was written by Python, and maybe 15% MATLAB, 5% by R. R is very popular in statistical community, but it's not very is not that popular in the whole machine learning community. But anyway, we highly encourage you to use all of this. Yeah, question. Oh, yeah, if you want to use Julia, yeah, feel free to do so. Yeah, Julia is popular in numerical people. It was said to be more efficient, even more efficient than MATLAB in some aspects. Yeah, feel free to use that. But it might not provide as many libraries as MATLAB can provide. Yeah. Other question regarding the programming language? Yeah, I mean, this is three popular languages programming languages we suggest you use, but you can choose whichever language you use. But make sure that they are runnable on Kate machines. It's machines in our computer labs, because we need to grade your homework assignments on Kate machines. So if you use some brand new language which is not runnable, we cannot test it, right? And we highly encourage you not to use C++ or C language or Java to implement algorithm, because that will make you very, very painful, right? Because yeah, if you use Python, use MATLAB, use R, use Julia, right? All matrix computation, matrix inverse, all kinds of stuff are automatically done, right, by one line of code. But if you use C++, you have to implement those things from scratch, unless you have like an infinite amount of time. I highly recommend not to do that. Although this is not, I mean, obligatory. If you prefer to do that, go ahead to do that, but it's not a wise choice, I believe. Yeah, yeah. Yes, yes. Yes, we highly encourage you to use basic libraries like math, computation, like especially matrix operations. Sometimes like even some optimization libraries we encourage you to use, but we will specify in the program assignments, in the assignment itself, right? So the only here is the point, right? So you're not allowed to call APIs to directly implement some machine learning algorithm. Like in sklearn, I know that you just use one function call to create the random forest. That's not allowed. Right? Other than that, in addition to that, you should leverage the existing libraries as much as possible. Right? Like for example, NumPy and SciPy in Python, and many default libraries in MATLAB. And as later we'll see that if we do nonlinear SVM, right? If you convert them into dual space and you're essentially solving a constrained convex optimization problem, we do ask you to use some SciPy optimization package rather than implement some constrained non-convex optimization from scratch. Right? Yeah, I think that's the major restriction. Right? Any question regarding this point?
Sorry, not this point, but just comments in general. How are like they graded for the machine learning algorithms? Like, is it based on like performance?
Yeah, that's a very good question. Yeah. So first, we're gonna run your algorithm to make sure that your algorithm's outcome is kind of consistent with your report, right? Your what you wrote in your homework assignment summation, right? And second, we're gonna look at, okay, if your results are reasonable. Reasonable means that you don't necessarily get 100% prediction accuracy. That's not possible, right? And even different people, when they implement the same algorithm, they might have different outcomes. That's very often, but it's unlikely that everybody else get 80% of accuracy. You get just 55. That usually won't be treated as the reasonable results, right? But if say if someone their prediction accuracy on the test set, same test set is 82, you got 81. There's nothing surprised. Your answer is correct. But this is just like part, we look at the result or the performance, right? But we'll also look at how you implement algorithm. We'll look at the flow of the algorithm. We'll double check if that really matches the correct implementation. Okay. So that means we will both look at your performance and also how you implement the algorithm, both white box and black box. Can you say guarantee what? No, there's no guarantee on that. Yeah, only a few models like their loss can be convex, like least square, or SVM related problems, right? For decision trees or neural networks, there will be no guarantee if this is convex. That's why I said, okay, we'll test this to check if your performance of your implementation is reasonably good. Not like you must get 95% accuracy, 100% accuracy. Any other question? Yeah. Oh, it's just there are a set of computer labs in the map and also in, I think, in web building. Like I know many students, they just finished these homeworks on those machines. As long as you can make your algorithm runnable on those kind of machines, that should be okay. But in most cases, like as long as your algorithm is runnable and generally on Mac or on Linux, it should be fine. Okay. But don't install additional libraries, right? Because I'm not sure. Like I think K machines are trying to cover as many common use libraries as they can, but they cannot guarantee like every library they will be installed. So don't try to implement too many libraries on your own computer if you decide to do that on your own computer. Yeah. Yeah, you can use that. Yeah, you want to use the IPython, right? IPython, yeah, feel free to do that. It's actually even easier for TAs to grade because just they can just start the server and just look at. Yeah. Another question? Yeah. Actually, the course, the homework assignments here, like they actually require minimum number of the libraries. You shouldn't expect that you have to install like 1 million libraries to make an algorithm work. It's not like that. Yeah. That's totally fine. Yeah, that's totally acceptable. Yeah. We won't ask you your course project. We'll talk about that later. But we won't ask your project. You must be very successful. You're able to write a paper to submit to New NIPS. That's not like that. That's just an experience, like to train you formulate a problem and you try to address that with some machine learning technique. You get some outcomes. You get some reasonable analysis. That's it. Other question? Yes. So I think that's a very good question. So your homework a summation, right? It must be PDF, and the PDF must be compiled from LaTeX. So LaTeX is I guess it's kind of like a golden standard for any technical report or scientific literature. So that's why we ask everyone to use that. Don't give me a Word document. And we also have like template. If you look at the release of our homework, we not only released the PDF, we also released the LaTeX template. So that means you just add it based upon the template, put the answer in. That's it. Very, very convenient. And And if you use Word to edit your formulas and edit your equations, it is a nightmare, I guarantee. Right? So I think, did I mention that here? Okay, we'll talk to that later. We'll talk about that later, but we encourage you guys to use the open source platform. It's called Overleaf. It's free. You just get an account with your Utah email, and just copy and paste the template we share with you, and make it and write something on their online editor, and click compile. It will generate PDF for you. It's very, very convenient. You don't need to install any LaTeX compiler or editor on your desktop. Other questions? Yeah. Yeah. We'll upload data sets to the Canvas as well. So those data sets have already been processed. So you just download that to your local machines and test them. Any other question? Okay. Yeah. Yeah, for cross project, 30%, right? So we need everyone to do one project that uses machine learning tactics to address some practical problems. And we'll later go, before we go to the detail about course project, like, there's one thing, right? So we need you guys to maintain your code about course project in some GitHub repository. And please make sure that your GitHub repository is private only, and only our TAs can access that. And because the reason is that we don't want anyone else to plagiarize your code, your project. But after that, feel free to open source your course project. And please set your GitHub repository private only and allow TM and TAs to access. And we also request you to submit a midterm project report and final project report. Okay. Now we can go to the details about this Coursera project. Again, the information, the detailed information is listed in our website, right? So there's a section called projects. So what kind of project? Basically, we have two types of projects. You're free to choose any one of them, right? So one type of project is called competitive project. This is an individual project. That means you can only do it by yourself. So we will open a in-class Kaggle competition. So how many of you have heard Kaggle? Oh, nice. So yeah, for someone else like who has never heard of Kaggle, Kaggle is very popular, perhaps the world's largest data science computation platform. So it has millions of like open problems. They provide data set, they provide the task description. Like many companies also hold some competition. They give some award, maybe $10,000 or even $100,000 to award the champion to solve that problem, right? So here in our class, we're gonna open an in-class Kaggle competition. That means that competition is only open to us, right? Now it's not open to public. And then your task, if you decide to do this competitive project, your task is to use the existing data set to address the prediction problem. And you can submit your results to the system. The system will evaluate and rank your performance. Okay? So we'll have some bonus points for you guys who rank as top 10, top 7, top 3, something like that. So this first type of project, the second type of project is called exploratory projects. So it's more like a research project. Right? So you can form groups, right? Groups of at most 2 to do this project. And you can pick up any project you want and which uses machine learning to solve some problem. So here is how we're gonna grade your projects, right? So we have like 4 milestones, right? The first one is called project selection or project type formation, right? So we'll soon release some kind of assignment to ask you guys to make choice, right? So you can choose to do the competitive project or exploratory project. If you do the competitive project, just let us know your choice, right? We know that you're just individual, you're doing solo, right? So if you're doing exploratory project, let us know your team, right? Again, for the Explorer project, you can do solo project as well, right? Or you can find a partner, right? Your team, right? But just let us know your choice and your teammates, right? And then we'll request you to submit a project proposal, right? Which was 10 points, right? And for a competitive project, we actually don't need to do anything because the problem has already been defined. What you need to do is that you need to register for the Kaggle competition and send us your username because we need to track you. We need to track your performance, and we prepare a big Excel sheet so that we can map your UID, your name, and also your Kaggle account, right? And if you choose to do an exploratory project, right, you need to submit 1-page document, right? Don't write too much. Writing 2 pages or more are highly discouraged, right? So you just need write 1 page of document, answer the 3 questions, right? First, who are the project team? Second, what problem do you want to address, right? For example, you want to use machine learning to predict the stock price tomorrow, right? If you can succeed, just let us know, right? I want to be the millionaire along with you, right? Or you want to use machine learning to solve some research problems here, like for example, I guess many of you are PhD students as well, right? If you happen to do some project related to machine learning, or you believe the machine learning can see your project, you say, okay, I want to do that. That's good. That's very good, right? Whatever problems you feel interested in, if it's worth being solved by machine learning, just write down it. Right? And third one, and that's also very important, why it is interesting. You need to explain why. So, yeah, you can do that. Yeah. Yeah, you can do that. I don't think there's a problem, but you must use some machine learning to address some problem. You must your project maybe use that for other classes, but you feel like okay, it won't matches this project. It's fine. This class, sorry, it's class. That's fine. Other question? Okay, so and third point is actually very important. You need to tell us why you choose this problem. Like why is interesting, why you want to use machine learning to address rather than traditional existing methods. You might say, okay, I believe that the computation cost is too high to solve this fluid dynamic simulation problem, right? I believe like using machine learning can drastically reduce the cost. That's fantastic, right? Or you believe that, okay, I can just collect a bunch of data points to predict the effectiveness of my bug killers, right? And otherwise it's very hard to predict, right? That's good, right? Just give us the reason, right? That's the project proposal, right? That will be released maybe in week 3 or week 4, right? And then during the middle of this class, we will request you to submit the midterm report. That will be really usually due right after the fall break, right? So we want you to submit a 3-page document talking about what you have done so far for a project, right? Here's the requirement of size font. Don't be too small, right? We want the size font to be 11, that is large enough, right? And for a competitive project, right? you should have made at least 2 non-dummy submissions on Kaggle. Means dummy submissions, that means you can randomly generate your prediction and submit to the system. That's just to test your registration is okay and everything works fine in this submission system, right? But at least you should try 2 efforts, right? And to make 2 efforts to submit to solve this problem and see what is the feedback. And based on the feedback, your report should describe what you did, any pre-processing that you need to do, and briefly outline your plan for the rest of the semester. Right? So there's some bonus. So by deadline of the report, I mean the midterm report, right? But not including late dates. Right? If you're submitting time, and you are ranked as top 10 in our ranking board, you will receive 3 bonus points. That's for the competitive. Right? If you choose to do the exploratory project, right, your report needs to include the 3 points, right? First, what you have done to reach your goal, right? You cannot say, okay, I just collect the data. That's not sufficient. You must have collect the data and also you have done something. Right? And what is your results, right? Of your preliminary trials, right? And then second question you need to answer is that what is your detailed plan for the rest of the project? You may say, okay, I tried decision trees or tried linear regression. I found it doesn't work at all. And the errors is surprisingly large, even worse than you simply use the mean of training data to make a prediction. That's ridiculous. There must be something wrong there. I guess that's because blah, blah, blah. And the next stage, first, I want to fix the problem. I want to find a problem. I might choose wrong features. Second, I'm going to use more fancy, more powerful models like convolutional neural network to address that. You just list this plan and the analysis. And third one, you need to list the references to the literature, right? This is like a basic requirement for any technical report, right? You need to leave the references, right? That's for the midterm report. Any questions so far? Okay, and then when we come to the end of the semester, right? We're going to ask you guys to submit a final report, right? And this should be the comprehensive summary of what you have done throughout the semester for a project, right? So the length of the final report is up to 6 pages, says 11 fonts. Again, we don't want you to write too many, right? Just to be clear, just to be concise and hit point. That will be excellent, right? This typically will be structured as a small research paper, and it should consist of the following content. First, what is the problem, definition, and motivation, right? And here, for the Kaggle competition project, you should explain the problem by yourself. Although we have defined the problem, right? You need to write it down in your project report, right? And and why it is important or interesting, why did you use machine learning techniques to solve that? This is kind of basically repeat your project proposal. So that's not too much work. And of course, if you're doing competitive project, you don't need to explain that because we know that is interesting, is important. Right? And then your solution, right? What kind of methods you have tried, and what's the results? What's the reason you choose those methods, right? So you need to list the details of the machine learning models and algorithm you choose or develop. Again, it won't necessarily to be like super successful, but you need to do that, right? And third part, you need to report experimental results, right? For example, you have a test 3 machine learning algorithms, right? Decision trees, perceptron, and deep neural nets, and each of them get training accuracy, test accuracy, and you have some like cross-validation to pick up the hyperparameters, all kinds of stuff. Please document them in your experimental section. And give some kind of analysis on why this is look good, why my deep learning is worse than linear models, right? And you should explain that. Or you should explain this is results is kind of like out of your expectation or kind of like consistent with your expectation, right? And finally, the future work, right? Of course, it's very likely that you won't be able to continue with the project, but as a scientific report, as a technical report, you always need to give some kind of vision for the future development of this one.
So like, unlike your solution, like in a research paper, a lot of times they're gonna get into like, use linear regression, this is the, the mathematical formula and all that stuff. Is that what you're expecting? Is like that?
No, you don't need to give too much math details on that,
Okay.
unless
You can get to a manager or something.
yeah. Because we cover a lot of details in the course. Of course, if you have develop a new algorithm, please specify the details. But if you just apply some existing algorithms, you can either list the reference or just say I have done something. Okay, and this final reports will takes about like 65 points. You can see that each section they have their points. So we'll just look at if your report covers every part of them, then we'll add points. We'll try to be as generous as possible, but if you miss some part of them, unfortunately, we're going to deduct that. Right? Okay, I think we have almost finished the explanation of the course project, as there's not much left for the remaining of the syllabus. So we're going to continue. We're going to quickly wrap it up at the beginning of the next lecture. Then we'll start introducing basic concepts and then start with the supervised learning. Okay, thanks, and have a great weekend. See you on next Tuesday.
Did you have any luck finding some office space?
Yeah.
Okay.
I found a space for you.
Cool.
Yeah. Sure. I'm sorry for that. Yeah, I just I went to the data lab yesterday.
Yeah.
And my previous allocated space was not sufficient.
Yeah.
So I found some empty table there,
Okay.
but I need to confirm with the guy who manages this.
Can I do
Yeah.
that? Is there an office I can go to?
Yeah. You know where the data lab is?
Yeah, I went to it. 3345, right?
Yeah. If you can stop by my office someday, like after 12, I can show you.
Okay.
Yeah.
Or today or tomorrow?
Today.
Okay.
Yeah.
Cool.
Yeah.
Where should we notify you about our selection of competitive or exploratory?
We'll release the assignment.
Oh,
We'll ask you guys to make a choice. You can I guess later you're gonna submit a PDF just indicating which project you're gonna do. If you're doing exploratory, who is your teammate? We'll make a documentation on that. Mhm.
hi, I sent you an email, I think, days ago about doing research potential.
Oh, okay. Yeah, what's your name?
I'm Divi.
What?
Divi?
Debbie.
Yeah, but I sent it to you.
Oh, okay. Yeah, let me.
I'm